Core Concepts for Open Architecture AV Design. Chapter 5. Network Audio. The goals for this chapter are: explore the embedded Dante network interface included with Symetrix Dante-enabled DSPs. Describe the uses for Symetrix analog I/O expanders. Be able to create, receive, and transmit buses for Dante and AES67 network audio signals using Composer. Control supported third-party AV devices on a Dante network. Explain AES67, where it is supported, and when it should be used. Understand the value of full-time redundancy options for networked audio. This chapter focuses on how Symetrix products integrate with network audio, which covers Symetrix Dante DSPs, Symetrix analog Dante I/O expanders, creating a network I/O receive bus, creating a network I/O transmit bus, third-party Dante device support, the network I/O user library, AES67, and Dante redundancy. Symetrix was one of the first manufacturers to adopt Dante as a multi-channel audio networking solution. Dante audio networking utilizes standard IP networks to transmit high-quality, uncompressed audio with near-zero latency. It is the most economical, versatile, and easy-to-use audio networking solution, and it is scalable from simple installations to large-capacity networks running thousands of audio channels. One of the benefits of every Symetrix Dante-enabled DSP is the embedded Dante network interface. The Dante interface is built into Dante-enabled DSPs instead of being an optional card, which lowers system cost. Symetrix provides an extra level of control over all Composer-supported Dante devices. All Symetrix Dante DSPs feature gigabit Dante ports and are capable of 64 transmit and 64 receive channels of Dante networked audio in addition to their analog I/O count. The Prism line of Dante DSPs feature a single Dante port and should always be connected to a network switch. Radius NX and Edge all feature dual Dante ports. These DSPs are capable of operating in either switched or redundant mode. While in switched mode, these ports enable the DSPs to either be direct connected or daisy-chained with up to 10 other Dante devices without the use of an external network switch. The Symetrix line of analog Dante I/O expanders increase the analog input and output capabilities of any Dante network when connected to a Symetrix Dante-capable DSP. The XN4, XOUT4, and XIO 4x4 have a single Dante port and are powered over Ethernet by an IEEE 802.3 AF Class 0 standard compliant switch, or by the included PoE injector. No other external power supply is needed or used. Because these three models have a single Dante port, they cannot be daisy-chained to each other. The XN12 and XOUT12 analog Dante expanders have dual Dante ports and can be configured in either switched or redundant modes. Because they have dual Dante ports, they can be directly connected to any Symetrix Dante DSP, or they can be daisy-chained with up to 10 other Dante devices without additional network hardware. Network I/O receive buses are created in the Composer site file to bus Dante and AES67 networked audio to the DSP. These buses can be created to receive audio from any Dante or AES67 enabled transmit device. Because Composer controls the receiving device, it makes permanent subscriptions for any audio channels being received. To create a receive bus for any Symetrix analog Dante I/O expander or third-party supported device, the process remains the same. First, add a DSP to the site view page from the toolkit, if not already present. Next, add in the analog Dante I/O expander and/or third-party supported Dante device to the site view page from the toolkit. Next, add in the analog Dante I/O expander and/or third-party supported Dante device to the site view page from the toolkit. In the Design View toolkit, expand the Network I/O menu, then expand the menu for Receive modules. Notice that the receive buses are automatically available for the CDT100 and the XN4. Now, add the buses to the Design View page. To add a third-party Dante device, expand the Third-Party Dante Devices section of the toolkit from the Site View page. Then add the desired device to the site file. Open the Design View page by double-clicking the radius NX. From the toolkit, expand Network I/O modules, then expand Receive modules. The AT-ND971 bus is automatically created and available. Add the AT-ND971 bus to the Design View page. In the Design View toolkit, expand the Network I/O modules and double-click New Network Receive module. Select Add New Bus. The new Dante bus window will open. Use this window to change the name, set the number of channels, assign an external source, choose multicast or unicast, add an AES67 stream, and name the individual channels. Next, check the box for external network device name. Then either type the device network name exactly as it appears in Dante controller, or if you are connected to the Dante or AES67 network with Composer, you can click one of the Browse buttons. Click the Browse Dante button to browse all Dante devices connected to the Dante network. Select the desired external Dante device the audio will be received from. The bottom portion of the window automatically displays the available channels and channel names that the device is transmitting. Select the individual channels to receive audio. To select more than one channel, hold the keyboard Control or Shift key and click on the desired channels. After the channels are selected, click the Create Unicast Bus button. Notice the network device name and channel names have updated in the Edit Dante Bus window. Select OK, then click OK in the Network Receive Module Properties window to create the Receive Bus. The Receive Bus is now added to the site file with the properly labeled channel names. Transmit buses are created in the Composer site file to bus Dante networked audio from the DSP to any Dante-enabled receive device on the network. To create a transmit bus, first add a DSP from the toolkit to the Site View page, if not already present. Then double-click on the DSP and open the Design View page. In the Design View toolkit, expand Network I/O modules, Transmit modules, then double-click or drag in a new Network Transmit module. Use the Network Transmit Module Properties window to change the name, set the number of channels, assign an external source, choose multicast or unicast, add an AES67 stream, and name the individual channels. Give the transmit bus a unique name. This is extremely important when transmitting audio to other Symetrix devices or supported third-party Dante devices. The bus name is used to assign which channels go to that device. Next, assign the number of channels for the bus, then select the bus type as either unicast or multicast, and select if this bus will stream AES67. The channel names are edited by either double-clicking the channel or by selecting a channel and then clicking the Edit Name button. The transmit has now been created and can be wired into the signal path. Notice that the bus displays its unique name and assigned channel names. The steps are the same to assign the transmit bus to either a Symetrix analog Dante I/O expander or supported third-party Dante device. Add the device to the Site View page from the toolkit. Then click the lower left corner of the X-Out12 to locate it. This opens the Locate Hardware window to locate the X-Out12 via the DSP. Locate the DSP in the file using the same steps outlined in the Receive Bus section of this chapter. Right-click the X-Out12 and choose Unit Properties. This opens the Properties window for that device. Select Edit Source in Dante Audio Reception window. The Select Dante Bus window will open. All available transmit buses for the site file are displayed. This is why it is important to label each transmit bus with a unique and recognizable name. Select the desired bus and click OK. The Unit Properties window updates with the assigned bus and channel names. Click OK. Once the file is pushed, Composer programs the device receiving the transmit bus with the device name and Dante channel names. This creates permanent subscriptions. LED control and/or feedback microphone switch operation, wireless battery life reporting, locating wireless microphones, and powering an amplifier on or off are some of the controls that can be managed from Composer for supported third-party Dante devices. In some cases, mic preamp settings are adjustable and phantom power can be turned on or off from Composer. This provides a single connection point for audio as well as control over these devices. Composer contains a continuously growing list of supported third-party Dante devices. Any Dante hardware can transmit and receive audio from any other Dante device connected to the same network. Symetrix takes these communications a step further with third-party supported devices. Not only can Symetrix make permanent subscriptions for the transmit and receive channels, but control of these devices is also possible across the Dante network. When configuring a system using Composer and third-party supported Dante devices, all subscriptions can be made from Composer. By allowing Composer to make the subscriptions, Dante Controller is not needed. Dante Controller can instead be used strictly as a troubleshooting tool. When the subscriptions are made using Composer, they are called permanent subscriptions. This means that anytime a device is power cycled, rebooted, or disconnected from the network, subscriptions are automatically recreated when the device is reconnected to the network. There is no need to repush the file or open Dante Controller to recreate the subscriptions as they are made automatically. Dante Controller is used to monitor the subscriptions and to demonstrate how powerful it is to use Composer for this operation. Symetrix offers different types of control over supported third-party Dante devices. The type of control differs from device to device. We'll cover some examples here. For the supported Shure Microflex Advanced and Microflex Wireless series of microphones, right-click the device module that was added to the Site View page and select Unit Properties. From the Properties window, input and verify the control interface IP address. Since the control communication is over Dante and not the control network, the control IP address must be in the same subnet as the Dante audio IP. To adjust the analog I/O settings, click on the Configure Shure Analog I/O button. From this window, the initial gain level for each microphone can be adjusted. Double-click the hardware module for the Microflex Wireless series to open a window that displays the microphone name, availability LED, status, type, RF signal percentage, battery capacity, battery health, identify buttons for locating microphones, microphone switch LED, and feedback LED. All of these items can be exported to SymView control screens and are capable of being assigned control numbers so they can be controlled and receive feedback from any third-party control system. For supported Audio-Technica microphones, right-click on the module and select Configure Audio-Technica Inputs. Use this window to mute or unmute the initial state, set the mic preamp, and enable or disable low-cut and phantom power. Audio-Technica microphones can also be configured by right-clicking the modules and selecting Unit Properties. Then select Configure Audio-Technica Inputs. The CDT100 can be configured by right-clicking the module and selecting Unit Properties. Then select Configure Clock Audio CDT100 MK2 Inputs. To configure the CDT100, right-click on the module and select Configure Clock Audio CDT100 MK2 Inputs. From this window, select On/Off LED Color, Enable Disable Phantom Power, and Enable Disable the default power on settings. The configuration process of the remote control features for any supported third-party Dante device is the same. In this example, we demonstrate configuring a mic switch and LED operation for the CDT100 MK2. First, add a DSP and CDT100 MK2 from the toolkit to the Site View page if not already present. Right-click the DSP and select Configure I/O Modules. Select 4-channel AEC inputs in the expansion card slot. Click OK to confirm, then double-click the DSP to open the Design View page. Next, from the toolkit, expand Network I/O Modules, Receive Modules, and add the Receive bus from the CDT100 MK2. Then from Mixers and Gains, Trims, add and wire a 4-channel trim module. Since Dante receive flows don't have digital trim, this module provides the ability to trim and mute the audio being received from the CDT100. Wire the trim module to the AEC aux inputs module. This allows the Dante microphone audio to be routed through the AEC. Since a signal wired to the AEC aux inputs module is being used instead of physical connections to the analog inputs, change the source from direct to aux on each input. Then close the AEC ends module. To send the mic audio to the far end, wire a 4-channel Master Gain Sharing Auto Mixer from the toolkit under Auto Mixers, Master Gain Sharing Auto Mixers. Then wire the mix out to the USB output module. This sends the auto-mixed signal out the USB port to the radius. Now that the signal paths have been created, the next step is to set up the control for the mic switches and LEDs. From the toolkit under Control Modules, Control Inputs, add a 4-button momentary module. Next, import a button processor supermodule from the supermodule library. There are specific supermodules built for the CDT100MK2 that also control the motorized arm function of the CDT100. This supermodule may be named CDT100 Processor with Unmute Delay. Any of the button processor supermodules work for controlling third-party mic switch and LED function. This example uses the CDT100 supermodule that has a built-in delay for the MK2 arm motor. This delays the unmuting of the microphone until the microphone is fully raised. That way the noise from the motor will not be picked up by the microphone. This supermodule is located in the third-party control folder. Add a remote logic output module to the design. The Properties window automatically opens and selects the next available output for that unit. In this case, it's the red LED for microphone number 1. With the button processor added, send a control signal from the DSP to the CDT100 to set the behavior of the LEDs. In the toolkit, under Control Modules, Control Outputs, add a remote logic output module. Please note, it is understood you may not have a physical clock audio device during this course, and this should be taken in stride. Additional note, logic functionality does not work unless online in Composer, which is also understood may not be possible while taking this course. Dragging in another remote logic output automatically selects the next available output for the mic. Wire the remote logic output module to the on or green output from mic number 1 of the button processor supermodule. The supermodule may have connection nodes for both on, G, and off, R, which may or may not be shown. Repeat this process until the outputs are wired from the button processor supermodule for all 4 microphones. The last output of the supermodule is for arm C control. The arm C is also selectable from the remote logic output. Next, open up the 4-button momentary module. Right-click on button 1, on button, and select Setup to Remote Control. Select third-party Dante remote mic switch CDT100. From the Select Analog Control drop-down menu, select switch number 1. This assigns the CDT100 mic switch number 1A to button number 1 of the momentary button module. Repeat this process until all the buttons are set up for analog control by the switch inputs for 4 microphones. Press Alt-M on the keyboard or go to Tools, superimpose assigned remote control numbers. Composer displays the control assignment of all objects. Repeat the steps as outlined in this section and assign the remaining 3 mic switches to the 3 remaining momentary buttons. Now that the mic switch and LED control has been assigned, the last step is to control the actual audio signal. The control currently assigned only controls the logic state of the unit and does not affect the audio. The following steps mute the audio of a specific channel depending on the current LED state for the microphone. In this example, when the red LED is activated, the appropriate channel is muted. Double-click the Master Gain Sharing Auto Mixer, right-click the mute button of channel 1, and then select Auto Assign next and used control number. From the Setup Remote Control window, Assign Remote Control Number will be the only option. Select Manually Enter Number and enter 1 in the box. Now the control number is superimposed over the mute button. Repeat the previous steps for the remaining 3 channels of the auto mixer. Opening the CDT100 supermodule, right-click on the Mic 1 Mute LED. Select Setup to Remote Control. Assign each mute LED to the corresponding control number for each mic mute button. Double-clicking the button processor supermodule will display its control screen. This supermodule provides control over each microphone and the arm C control individually. Each microphone can be set to push to talk, push to mute, toggle, or disabled. The control screen contains LED indication of the active setting for each microphone. These LEDs indicate if the button is pressed and which LED is active. Each object in this control screen can also be assigned a control number. This means that all these controls can be exported to a SimView control screen, or they can be controlled from any third-party control interface. The AES67 standard provides interoperability between different forms of audio over IP. AES67 is currently supported by Dante, Ravenna, Livewire, and QLAN. Symetrix Dante-enabled DSPs are compatible with AES67, but they are not AES67-specific hardware. AES67 stream assignments are handled by the receiving device, and streams will only appear as a transmitter in Dante controller. AES67 transmit streams from a Symetrix Dante-enabled DSP will not be assignable in Dante controller. AES67 is capable of unicast and multicast communication. However, Dante's implementation of AES67 currently only supports multicast. When two Dante-enabled devices are passing audio between each other, they will always use Dante for the communication regardless of AES67 streams. Audinate's Ultimo chipset does not currently support AES67, though Ultimo X or Ultimo X4 do. Create AES67 receive buses by using the generic network receive modules. Using a radius NX and QSC QSys Core 110F, open the toolkit, expand network I/O modules, and expand receive modules. Double-click or drag in a new network receive module. The network receive module properties window opens automatically. Click the button to add new bus. The new Dante bus window will open. Select the box for external network device name. Select the box for an AES67 stream, then click the Browse AES67 button. Select the desired AES67 multicast stream from the list. Click the Select AES67 Stream button. The new bus window is now updated with the AES67 stream information showing device network name and channel names. The new AES67 receive bus is available in the Network Receive Module Properties window. Click OK. The new AES67 receive bus has now been created. To create an AES67 transmit bus, start by selecting New Network Transmit Module from the Network I/O Modules section of the toolkit. The Network Transmit Module Properties window will open. Edit the name of the transmit bus. Naming of transmit buses is very important for organization and routing. Select the number of channels in the transmit stream. Change the bus type to multicast and check the Add AES67 stream box. Remember, AES67 is capable of unicast and multicast communication. However, Dante's implementation of AES67 currently only supports multicast. Name the individual transmit channels. Click OK. The transmit bus is added to the site file. Notice the AES67 identifiers in the toolkit and the module. These help to easily identify the type of module on the network I/O bus. All Symetrix Dante devices ship with Dante in the default switched mode. Dante offers a full-time redundancy option with permanent primary and secondary audio transmission. Redundancy requires a second network, using either a second physical switch or a VLAN to isolate the network traffic. A second physical switch is the recommended configuration. When in redundant mode, audio data is transmitted on both the primary and secondary networks simultaneously. In the event of a failure on one network, audio still continues to be transmitted via the other network. If the Dante hardware is physically cabled in a redundant network configuration while in switched mode, traffic from the primary Dante port transmits out the secondary Dante port while the secondary Dante port transmits out the primary Dante port. This creates a data feedback loop on the Dante network that will crash the Dante networks. To change from switched mode to redundant mode, first cable the Dante network in switched mode. In other words, if using an external switch, make connections only to the primary jack. If more than two devices are used without an external switch, daisy chain from one unit's primary port to the next unit's secondary port. In Composer, go to Tools, Network I/O Manager, Configure Dante, then select Redundant Network. Next, push the file to go online with the units. This will take slightly longer than usual as the Dante units change their mode. Then power down the units. Cable the Dante network as appropriate for redundant mode. Connect the primary and secondary to separate switches like the above diagram shows. Power on the units, then repush the file and go online. To change from redundant mode back to switched mode, first, power down or disconnect the entire secondary Dante network. In Composer, go to Tools, Network I/O Manager, configure Dante, then select Dante separate and daisy chainable. Next, push the file to go online with the units. In summary, Symetrix's Dante-enabled DSPs include an embedded Dante network interface. Symetrix's analog Dante I/O expanders increase input and output capabilities of any Dante network when connected to a Symetrix Dante-capable DSP. Network I/O receive buses are created in Composer to bus Dante and AES67 networked audio to DSPs. Buses can receive audio from any Dante or AES67-enabled transmit device. Transmit buses are created in the Composer site file to bus Dante networked audio from the DSP to any Dante-enabled receive device on the network. Composer can manage LED control, microphone switch operation, powering amplifiers on or off, and much more for supported third-party Dante devices. The AES67 standard provides interoperability between different forms of audio over IP. AES67 is currently supported by Dante, Ravenna, Livewire, and QLAN. Dante offers a full-time redundancy option with permanent primary and secondary audio transmission.